The advanced question says, a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. The data was used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. Determine if there is a significant difference in growth between the tomatoes with additives and the tomatoes without. Do not fear the phantoms. First, we define our parameter. Our parameter is mu of D equals the mean difference in growth between tomatoes with additives and without additives. Next, we define our null hypothesis to be mu of D equals 0, there is no difference, and our alternative hypothesis to be mu of D is not equal to 0, there is a difference. We will use an alpha of 0.05. The assumption/condition of SRS is stated in the problem. It is also stated in the problem that the assumption of normality is not unreasonable. The experiment/test is matched pairs, so we will use a one-sample t-test. The formula we'll use is t is equal to x bar, or sample mean, minus mu over s divided by the square root of n. The sample mean is negative 2.05, the mu is 0, the s is 1.163, and n is 12. S over the square root of n is also known as standard error. We are given s, n, and the standard error. 1.163 over the square root of 12 is equal to 0.336. So for this problem, whether you use 1.163 over the square root of 12 or 0.336 in the equation, you get the same answer of a t-score of negative 6.0019. To obtain a p-value for a t-score of negative 6.0019 by using Table C, we use a DF of 11 because our sample size of 12 minus 1 equals 11, and look for the probability p that negative 6.009 falls under. Negative 6.0019 is not on Table C, so our p-value has to be less than 0.0005. The calculator will give a more specific answer of 0.00008902. Both are correct. Now we either reject or fail to reject the null hypothesis. We reject the null hypothesis that there is no difference in growth between tomatoes with additives and without additives because our p-value of 0.00008902, or p is less than 0.0005, is less than our alpha of 0.05.